Hello everyone. So today we'll be solving this IMO 1963 problem. You might have solved this trigonometric identity, but today I'll be showing you a very elegant way, a geometric proof to this problem. So let's get into it. As you can see, this minus sign right here, I can see it's breaking the symmetry sort of thing, right? If it would have been a plus sign, it would look much better. So let's just make it plus. It is not very hard. I can write cos 2 pi by 7 as cos of pi minus 5 by 7, right? Because 7 minus 5 and you will get the same thing. And we all know that cos of pi minus theta is nothing but minus of cos theta. Now plugging this back into this LHS of our problem, we get cos pi by 7 as it is. Now minus minus becomes plus, cos 5 pi by 7 plus cos 3 pi by 7. Rearranging, I can write cos pi by 7 plus cos 3 pi by 7 plus cos 5 pi by 7. Now I lost my the 2 term here, the 2 factor, but still I am getting some sort of pattern, right? 1, 3, 5. So it will be pretty good, as you will see ahead. Now, instead of multiplying this expression, multiplying and dividing by sine pi by 7, which is the usual way to do it, or uh, considering the 7th or 14th roots of unity, which also is another way which also can be used to solve this problem, I'll be showing you another geometric way. So let's get into that. Now I want all of you to consider this regular heptagon of side 1 unit. And I have drawn this in such a way that the vertex, one of the vertex lies at origin, and straight opposite to that vertex is one side of heptagon which is horizontal. Now I know the interior angle of a polygon is given by this formula. I hope you must all know that. It is something like this. Now plugging n equal to 7 for heptagon, I get 5 pi by 7, isn't it? So 5 pi by 7, this is this angle. Similarly, if this is 5 pi by 7, this has to be pi by 7 and pi by 7, right? So if this is pi by 7 and this is of 1 unit, I can use the polar form to write the coordinate of this B point, which will be nothing but r cos theta comma r sin theta. R is 1, so I can write cos pi by 7. I'll just prefer writing x coordinate because it is of only use here, right? Now this angle is also 5 pi by 7, right? Extending this line, I get this angle to be 2 pi by 7 because this whole should add up to pi. If this is 2 pi by 7, extending this to touch the x-axis, I get the angle of BE line from x-axis to be the sum of these two interior angles, which is nothing but 3 pi by 7, as this is pi 2 pi by 7, right? So this makes an angle 3 pi by 7 with BE makes an angle 3 pi by 7 with the x-axis. Hence this coordinate is nothing but cos 3 pi by 7. The x coordinate, y coordinate is sine 3 pi by 7. Now similarly, I wrote this is 1 pi by 7, right? So this is nothing but cos 5 pi by 7, right? Similarly, you can follow the procedure and do that stuff. Now my question asks me to tell the value of cos pi by 7 plus cos 3 pi by 7 plus cos 5 pi by 7. Now if I look carefully, this vector, okay, this vector plus this vector plus this vector, the resultant is this vector right here, this vector right here. Now if I need the x coordinate of the resultant vector, which is this g point, look closely, this g point's x-axis coordinate is nothing but half. How can I claim that? Because this side is 1 unit. This exactly cuts in between because it is a regular heptagon. I have drawn origin in exactly opposite to that side. So this is half and this is half. If this is half, the distance of this from y-axis, which is the x-coordinate of G point, is nothing but half. So this, what I'm exactly saying is, this distance, this is half. And this is what I should be getting by adding these vectors and just looking at the x coordinate. Hence cos pi by 7 plus cos 3 pi by 7 plus cos 5 pi by 7 gives me half. You see, this is completely geometric proof to this problem. I could have solved this using some other ways which are more easy to understand or like straightforward ways, but I think this is mathematics, right? And one should always be keeping its eyes open to look into another ways of solving these problems and more elegant ways to solve these problems. This is very beautiful, right? I was just so happy after looking at this solution, so I felt like sharing with everyone. I hope you enjoyed this video. I hope you like this solution. If you have any doubts, you can post it in comments. Thank you all.